Your FastMCP 2 production auth setup needs more than just a signing key. It requires encrypted storage too, or you're leaving tokens exposed in Redis. We'll walk through the complete production configuration, showing exactly where to add the FernetEncryptionWrapper around your RedisStore and why storage encryption key must be separate from your JWT signing key. You'll see the full implementation, including the required imports and environment variables, to ensure tokens stay secure at rest.
Auth equals GitHub provider. Client ID equals OS. Environ GitHub client ID. Client secret equals OS. Environ GitHub client secret. Base URL equals https://yourserver.com. Hash explicit keys required for production. JWT signing key equals OS. Environ JWT signing key. Hash persistent network storage required for production. Client storage equals RedisStore. Host equals Redis. Example, com, port equals 6379.
This demonstrates the production-grade OAuth token management pattern in FastMCP 2, where external provider credentials are encrypted before storage and replaced with internally signed JWT tokens. The pattern enforces strict separation between authentication flows and token persistence, requiring explicit cryptographic keys for both JWT signing and storage encryption. The key distinction is that all external tokens must be wrapped in encryption layers before entering persistent storage, with separate key material for each security function. The implementation follows a clear security pipeline. External OAuth tokens are received, immediately encrypted with a dedicated storage key, then stored in Redis while new FastMCP signed JWTs are issued to clients. This design mandates two independent cryptographic systems, one using JWT signing key for token issuance, another using storage encryption key for credential encryption, with RedisStore providing the persistent backend. The pattern's effectiveness comes from treating token storage as a separate security domain from token signing, preventing credential exposure even if one subsystem is compromised. This approach solves the critical problem of plaintext token storage in distributed systems while maintaining proper token audience boundaries. It's required for any production deployment where token leakage could grant excessive permissions across service boundaries. The complete implementation must include FernetEncryptionWrapper from key-value AO, wrappers, encryption using cryptography, Fernet. Fernet as shown in the official storage backend's documentation, with both signing and encryption keys provided as separate environment variables. Let's break it down line by line.
Auth equals GitHub provider.
This initializes GitHub OAuth authentication using GitHub provider, but the shown configuration is incomplete for production. The official storage backend's documentation requires wrapping RedisStore in FernetEncryptionWrapper using a separate storage encryption key environment variable. For a production-ready implementation, you must add a Python from key-value AO wrappers, encryption import FernetEncryptionWrapper. From cryptography, Fernet import Fernet. Storage equals FernetEncryptionWrapper. RedisStore host equals Redis. Example, com, port equals 6379. Fernet OS environ, storage encryption key. Then pass this storage as the client storage parameter instead of the plain RedisStore. The JWT signing key and storage encryption key must be distinct environment variables.
Client ID equals OS. Environ GitHub client ID.
This pulls the GitHub OAuth client ID from environment variables, following secure credential practices. Environment variables prevent secret hardcoding while enabling different configurations across development, staging, and production environments. For production use, you must wrap the RedisStore with FernetEncryptionWrapper using a separate storage encryption key environment variable, as shown in the official storage backend's documentation. The complete implementation requires importing Fernet from cryptography, Fernet and FernetEncryptionWrapper from key value, wrappers, encryption.
Client secret equals OS. Environ GitHub client secret.
Loads the GitHub OAuth client secret from environment variables following secure credential practices. This secret authenticates your application with GitHub's OAuth service, enabling token exchange during the OAuth flow. For production, this must pair with encrypted storage. Never use plain RedisStore. The complete implementation requires wrapping RedisStore with FernetEncryptionWrapper, using a separate storage encryption key environment variable for the encryption layer.
Base URL equals https://yourserver.com.
Configures the GitHub OAuth provider to use your self-hosted GitHub Enterprise server instead of GitHub.com. This is required when authenticating against internal GitHub Enterprise instances. For production use, you must wrap the RedisStore in FernetEncryptionWrapper using a separate storage encryption key environment variable. The official implementation requires these imports and structure. Python. From key value, wrappers, encryption import FernetEncryptionWrapper. From cryptography, Fernet import Fernet. Hash production-ready implementation. Auth equals GitHub provider. Client ID equals OS. Environ GitHub client ID. Client secret equals OS. Environ GitHub client secret. Base URL equals https://yourserver.com. JWT signing key equals OS. Environ JWT signing key. Client storage equals FernetEncryptionWrapper. Store equals RedisStore. Host equals Redis. Example, com, port equals 6379. Fernet equals Fernet, OS. Environ storage encryption key. The shown example is incomplete. Never use unencrypted storage in production. JWT signing key and storage encryption key must be separate environment variables.
Hash explicit keys required for production. JWT signing key equals OS. Environ JWT signing key.
This configures JWT signing using a dedicated key from environment variables, required for secure token generation in production. The key must be separate from storage encryption keys, with JWT signing key and storage encryption key as distinct environment variables. For complete production security, you must wrap the RedisStore with FernetEncryptionWrapper from key value, wrappers. Encryption. Using cryptography, Fernet for encryption. This example shows the minimal setup but omits the encryption layer required for production deployments.
Hash persistent network storage required for production. Client storage equals RedisStore. Host equals Redis. Example, com, port equals 6379.
This configures Redis as persistent OAuth session storage, but the example is incomplete for production. The official documentation requires wrapping RedisStore with FernetEncryptionWrapper using a separate storage encryption key environment variable. The complete implementation needs Python. From key value, wrappers, encryption import FernetEncryptionWrapper. From cryptography, Fernet import Fernet. Auth equals GitHub provider. Hash other parameters. Client storage equals FernetEncryptionWrapper. RedisStore host equals Redis. Example, com, port equals 6379. Fernet OS environ, storage encryption key. This ensures tokens are encrypted at rest while maintaining JWT signing separation. The shown example would store tokens in plain text, creating a security vulnerability. This closing parenthesis completes the GitHub provider initialization. but the shown configuration is incomplete for production. The official documentation requires wrapping RedisStore in FernetEncryptionWrapper using a separate storage encryption key environment variable. For production compliance, you must implement a Python from key value AO wrappers, encryption import FernetEncryptionWrapper. From cryptography, Fernet import Fernet. Encrypted storage equals FernetEncryptionWrapper. RedisStore host equals Redis. Example, com, port equals 6379. Fernet OS environ, storage encryption key. Then pass encrypted storage as client storage to GitHub provider. The JWT signing key and storage encryption key must be distinct environment variables. Production-grade OAuth storage. The GitHub provider configuration demonstrates FastMCP's authentication foundation, but requires explicit encryption for production deployments. The shown RedisStore implementation is incomplete without FernetEncryptionWrapper from key value. AO wrappers. Encryption, which the official documentation mandates for encrypting OAuth tokens at rest using cryptography. Fernet. Both JWT signing key and client storage must use separate environment variables, JWT signing key and storage encryption key, to properly secure tokens across server restarts.
The storage that remembers everything must first learn to forget its own keys.